Okay, friends, welcome to a terrific Tuesday. I'm going to go ahead and review the answers to your Standard 3 quiz. I want you to use this as a study guide for our first 9 weeks test. I will post that test on Friday for you to work on. Okay, so for this first problem, we're going to multiply or divide decimals by powers of 10. So I'm going to start with 3 thousandths times 10 to the third power. So the first thing you want to ask yourself is, what is the value of 10 to the third power? So we're going to be multiplying 3 thousandths times 1,000. Now the easiest way to do this is rewrite your number and then move your decimal point 1, 2, 3 place value positions to the right because we have 3 zeros in 1,000. So I'm going to take my decimal point and move it 1, 2, 3 place value positions to the right. And so the location of my decimal point is now here, showing my product as 3 wholes. So you can write your answer as 3, or you can put the decimal point in the 0. They have the same value. Okay, next we're going to multiply 2 and 45 hundredths times 10 to the third power. Now remember, the best way to learn from a math video is to pause the video while you attempt to solve the problem on your own. Then unpause the video and double check your work with what I'm doing. I'm going to begin by figuring out the value of 10 to the third power, which is 1,000. This 3 here, the exponent 3, tells me that I'm multiplying 10 times 10 times 10, which is 1,000. I'm going to rewrite my number and then add a 0 as a placeholder and move my decimal point 1, 2, 3 spots to the right as I multiply. I'm moving it 3 spots because 1,000 has 3 zeros in it. So I'm going to move this decimal point 1, 2, 3 spots. And so my product is going to be 2,450. Next, we're going to divide 567 thousandths by 10 to the second power. So we're going to divide 567 thousandths by 100. That's the value of 10 to the second power. Rewrite your number. Whoops. And then add some zeros as a placeholder. This number is going to get really, really, really tiny because when you divide, your decimal point moves to the left instead of to the right because your number is getting smaller. So I'm going to move my decimal point 2 place value positions to the left because 100 has 2 zeros in it. So I'm going to take my decimal point and move it 1, 2 spots to the left, and now I have this super duper tiny number. So my quotient, or my answer, is this, and you can round this number to the nearest thousandth. This digit is in the thousandths place, and my 6 is greater than 5, so that means I will round my digit in the thousandths place up. So this is my quotient, 6 thousandths. Okay, last problem. I'm going to divide 92 and 4 hundredths by 10 to the second power, which means I'm dividing 92 and 4 hundredths by 100, That's the value of 10 to the second power. And to find my quotient, or my answer, I'm going to rewrite my number and move my decimal point 2 spots to the left. 1, 2. So my quotient is going to be 92 hundredths. And I'm going to round it. See, this is my quotient exactly, but I'm going to round it to the nearest hundredths place. There we go. Next, we're going to record these two decimals as a fraction. Now remember, when we're writing a decimal as a fraction, we need to have a numerator and a denominator that represent the value of the digit. So your numerator is going to be the digit itself, which is 3, and the denominator needs to represent your number of equal pieces. So the digit in the tenths place tells you that we have 3/10 of a whole. So that's how you would write that as a fraction, 3/10 of a whole. For number 3, we have 4 and 6/10. So this is actually going to be a mixed number. A mixed number means you have your wholes, or your ones, and then you have your decimal amount. So here we have 6/10 of a whole. 6 is going to be your numerator, and tenths is your denominator. So your denominator is going to be the place value word that goes with the digit. Okay, next we're going to go the opposite direction, and we're going to take these fractions and convert them to a decimal. So we're going to start with 6 and 24 hundredths. So we know we're going to have 6 wholes, and we need to have our decimal point, 24 hundredths. The digits, these digits of the hundredths place here do not actually show up in our decimal form. They are understood by the fact that these digits, the 2 and the 4, are in the place value position they're in. So you're not going to add these digits 100 to your decimal form. 6 and 24 hundredths. And then for number 5, we have 4/10. So we have no whole numbers, no ones, and 4 out of 10, 4/10. So that's how you would write that in decimal form. All right, this is the problem that requires us to put the digits in the place value chart. And notice that our whole number is made up entirely of 7s. Each 7 is going to have a different value. Okay, so let me make this a little bit bigger. I think that will be easier. Okay, now I'm going to represent these bigger 7s with exponents because that will be a little bit more space effective for me. So I'm going to show 700,000 with a value of 7 times 10 to the, let's see what power I need to have. 1, 2, 3, 4, 5. 10 to the 5th power should get me to my 100,000s place. Oh, let me get rid of that. Okay. All right, and then this 7 has a value of 7 times 10 to the 4th power. You could also just write it like this, 70,000. That would be correct also. This next 7 has a value of 7 times 10 to the 3rd power, or 7,000. The 7 in my hundreds place has a value of 7 times 10 squared, or 700. The 7 in your tens place has a value of 70. And this 7 has a value of simply 7 ones. The 7 in your tenths place you can write as 7 groups of 1/10, or you could write it in word form if you wanted, 7/10. And then last but not least, we have 7 groups of 1/100, or 7/100. Okay, for these last two questions, we're going to explain our system as we understand it for place value. Number 7 says, does place value work the same way with decimals as with whole numbers? How is it alike and how is it different? Number 8 says, explain the pattern that you discovered about the value of the digits as you moved left along your place value chart. Then explain the pattern that you discovered about the value of the digits as you moved right across your place value chart. Okay, so let's talk about number 8 first, actually, because this is the one that you're going to see this question over and over again this year. They want you to understand that as you move across your place value chart, let's start with hundreds, tens, ones, and tenths. Every time you move one spot to the right, your numbers are getting smaller by 1/10, or being divided by 10. So the digit in this tens place, let's take our 777 and 7/10. The 7 in the ones place divided by 10 gives you the 7 in the tenths place. The 7 tens, or 70, divided by 10 equals the 7 in the ones place, or 7 ones. 700 divided by 10 gives you 70, or 7 tenths. So each digit in your place value chart is divided by 10 as you move from left to right. And then going in the other direction, when you move from right to left, you are multiplying by 10. So 7/10 times 10 equals 7 ones. 7 ones times 10 equals 70, or 7/10. 7/10 times 10 equals 700, or 7 groups of 100. That's what they want you to understand. They want you to understand that our place value system is built on groups of 10 increasing across each place value position. Okay, for this last question, I kind of went a little bit out of order, but let's go back to number 7. Let's think about the ways that place value is the same when you're working with decimals, and let's think about ways in which place value is different when you're working with whole numbers. So I'll just give you, just to kind of get you started, I'll give you one thing that I know is the same and one thing that I know is different, and then you guys tell me what you come up with, okay? So one thing that is the same about place value with whole numbers or with decimals is that the value of the digit in one place value position is 7 times greater than the value of the digit in the next place value position. So each digit's next door neighbor is 10 times greater. And that is true whether you're talking about whole numbers, like here, the 7 in my tens place is 10 times greater than the 7 in my ones place. So 7 ones times 10 will give you 7 groups of 10, or 70. And that also works with decimals. If you have 7/10, 7/10 times 10 will give you 7 ones. So that is true whether you're talking about decimals or whole numbers. What is different between whole numbers and decimals is using zeros as placeholders. The rules for using zeros as placeholders is different in decimal form and with whole numbers. More on a fresh sheet of paper because I think we'll be confused if we go to another. So let me explain that a little bit. Another page. Okay, so when you're using a 0 as a placeholder with a decimal, like 7/10, you can add a 0 to the end of that and it does not change the value of the number. This has the same value as 7/10, and 7/10 has the same value as, as 7/100. So you can add as many zeros onto the end of a decimal amount as you want without changing the value of the number. But with whole numbers, that's not the case. I can't just, if this is 7 ones, I can't just add a 0 onto the end of that and have it have the same value. So zeros have a different meaning in whole number form as they do in decimal form.